structured light scanners have been on the market for some time now. They are mainly used for quality control or reverse engineering. In terms of quality control, the whole process is to mirror the physical model to a 3D model and then compare it to a CAD reference model. When it comes to quality control, the accuracy parameters that a 3D structured light scanner should achieve are very important. A very important element in the case of selecting a 3D structured light scanner for the size of a detail is its working area. For very small workpieces, the accuracy requirements are very high, often expressed in microns. To meet these accuracy, choose a scanner with a very small footprint. This is because the smaller the work area of the scanner, the higher its accuracy. For very small workpieces, where customer requirements are very demanding, a scanner with a very small working area should be used. This is because the smaller the scanner's working area, the greater the scanning accuracy. An additional thing that is very important is the granularity of the data obtained. In the case of scanning elements of about 2 cm, we want to achieve the highest possible accuracy of the point cloud and to reproduce as many defects and damage as possible. A dedicated scanner for small parts allows us to detect such damage on the surface by providing a high-density grid of points. This is extremely important when it comes to identifying potential problems. If the scanner will provide a low-density point cloud, it is likely that most of the object's defects will be missed by the scanner. Therefore, a dedicated scanner with a high point cloud density should be used in these cases, which will allow you to precisely scan the edges. Such edges on a high-density point cloud will be very sharp, not as in the case of a low-density point cloud, where they will be rounded and gentle. In the case of a high density of 6 spots on a high-precision scanner, we can perform quality control on these edges to look for damages, deficiencies, or any other defects. When scanning small parts, these components are often mounted in special frames that have been calibrated in advance for precise accuracy. Attaching such an element allows you to connect all groups of scans very precisely in order to obtain the correct 3D data for quality control. The 3D scanner can be used, for example, in the automotive industry, where the requirements of customers regarding the production of individual elements on the production line are very high.